70 million years ago, at the end of the Cretaceous period, something catastrophic happened. In just a matter of days, or even hours, the dinosaurs vanished from our planet. But what actually happened? Were they all wiped out by an asteroid impact, or is there more to the story? And how did life recover after such a cataclysm? Hello, it's me, and this is my channel. Today, we are going to be talking about the day that the dinosaurs died. Did they die over millions of years, slowly dying out, like many species do? No way. This extinction was catastrophic and quick. It has been named the Cretaceous-Paleogene Extinction Event, and while the asteroids are given most of the credit for the sudden disappearance of the dinosaurs, recent studies have started to challenge this long-held theory. So today, we are going to go through some terrifying new theories that could change everything we know about the day the dinosaurs died. Let's get into it. First, let's start with some facts about this mysterious event. There are so many unanswered questions surrounding the end of the Cretaceous period. Scientists have never been able to fully understand what caused the mass extinction or why it affected some animals more than others. But here are a few things that scientists do know. First, 70 million years ago, Earth's climate was much warmer than it is today. Scientists believe that at the end of the Cretaceous period, Earth experienced an ice age. They say that temperatures suddenly dropped by 5 degrees Celsius, which would be around 9 degrees Fahrenheit. So not a huge difference, but one that had massive consequences for the planet and its inhabitants. During this time, sea levels also fell, meaning that the world's oceans shrank dramatically in size. These major changes in temperature and rainfall patterns resulted in the formation of deserts in areas that were once tropical forests. These dramatic environmental changes are thought to have paved the way for the mass extinction. Life on Earth was already struggling before the asteroid impact, if there was one. So now, let's talk about the asteroid impact hypothesis. While the exact cause of the extinction event remains uncertain, it is widely believed that an asteroid impact played a significant role. This theory gained traction after the discovery of the Chicxulub crater in Mexico's Yucatan Peninsula. Radiometric dating revealed that the crater is indeed from the end of the Cretaceous period, approximately 66 million years old. The asteroid itself was estimated to be around 6 miles wide. To put that into perspective, that is almost 10 times wider than the Burj Khalifa, the world's tallest building. It was also about 2 kilometers deep, which is deeper than the Mariana Trench, the deepest part of the ocean. It's hard to imagine any living thing surviving such a devastating event. But the details surrounding this massive asteroid impact are actually quite murky. First of all, there is evidence that the asteroid didn't kill off all of the dinosaurs. Some species of dinosaurs lived on for another 100,000 years after the impact. So while the impact may have contributed to their extinction, it wasn't entirely responsible. Second, recent research has found that the asteroid impact may have triggered, rather than caused the extinction event. One study published in the journal NUS concluded that the impact only hastened the demise of the dinosaurs, who were already struggling due to the changing climate. And finally, there is the issue of iridium. When the asteroid theory first came out, scientists studying the KT boundary layer, a thin band of rock found all over the world that separates the Cretaceous and Paleogene periods, discovered high levels of the element iridium. They theorized that iridium is rare on Earth, but abundant in space. So it must have come from an asteroid. However, further analysis of the KT boundary layer revealed that the iridium is actually widespread and unevenly distributed. It's not limited to the actual boundary between the two time periods, which means it could have come from multiple smaller asteroids hitting the Earth over a long period of time. It's also possible that the iridium came from a supervolcano eruption rather than an asteroid impact. This brings us to the next theory, the Deccan traps. The Deccan traps are a large igneous province or lip, which are basically vast expanses of igneous rock. The Deccan traps are located in the Deccan Plateau in India, and just like the KT boundary layer, they also contain high levels of iridium. Scientists believe that around 66 million years ago, a massive flood basalt eruption occurred in the region. This volcanic eruption lasted for at least 1 million years, spewing massive amounts of lava and ash into the atmosphere. So large volumes of greenhouse gases were released during the eruption, leading to global warming and possibly even a runaway greenhouse effect. Global warming can cause mass extinctions when species cannot adapt quickly enough to the changing environment. The warming could have also led to rising sea levels, which destroyed coastal habitats and disrupted ocean currents, leading to more extinctions. Rising temperatures may have also intensified the greenhouse effect, leading to more heat being trapped in Earth's lower atmosphere and further driving up temperatures. So the Deccan traps may have caused the extinction event all on their own, without the help of an asteroid. In fact, some scientists believe that the asteroid only hit the Earth because it was already weakened by the eruptions of the Deccan traps. If this is true, it means that the asteroid impact wasn't a singular event that instantly killed off all of the dinosaurs, but rather the death of the dinosaurs was a slow process that occurred over hundreds of thousands of years. And what about the Ice Age? How does that fit into the timeline? Well, the asteroid impact theory suggests that the impact led to a sudden ice age. This theory is backed up by the discovery of ice layers in several parts of the world, including the Laptev Sea in northwest Russia and the Seymour Islands in Antarctica. According to NASA, these ice layers formed within a decade of the asteroid impact, suggesting that the impact triggered a rapid climate shift. However, it's important to note that the presence of ice does not necessarily indicate an ice age. Rather, it may have formed during a brief period of intense cold immediately following the impact. If the asteroid did cause the ice age, then it must have also caused the rising sea levels. As temperatures dropped and water vapor froze in the atmosphere, it would have led to precipitation and the formation of glaciers. The growth of glaciers could have taken place over several centuries or millennia, eventually leading to a rise in sea levels as they melted. However, recent research suggests that rising sea levels may have actually contributed to the extinction event. One study published in the journal Science Advances proposes that rising sea levels caused by melting glaciers may have drowned coastal ecosystems, destroying habitats and disrupting food chains. So the asteroid impact theory may be incorrect. While it's still widely accepted, it's no longer considered to be the entire story. Scientists are starting to believe that a combination of factors, including volcanic activity, climate change, and possibly asteroid impacts, led to the mass extinction. Okay, so if the asteroid theory isn't true, then how exactly did life on Earth recover? Life on Earth did eventually recover from the mass extinction, but it took a long time for the planet to repopulate. According to NASA, mammals were among the first vertebrates to repopulate the Earth. After the extinction event, they experienced an adaptive radiation, which means they rapidly diversified into new species. This allowed mammals to take advantage of the new ecological opportunities that arose after the extinction of the dinosaurs. Birds, which are the descendants of theropod dinosaurs, also survived the mass extinction and went on to diversify and thrive. The ancestors of modern birds were small, feathered dinosaurs that lived alongside the larger meat-eating dinosaurs. Once the larger dinosaurs went extinct, the smaller birds were no longer competing for resources with them and were free to expand into new habitats and evolve into new species. It's interesting to note that after the mass extinction, mammals and birds experienced a burst of evolution, but other groups of animals did not. For example, insects and crustaceans continued to be mostly small for millions of years. This suggests that the mass extinction had a differential impact on different groups of animals. Some groups were able to bounce back quickly, while others took much longer to recover. So there you have it. The day the dinosaurs died was not a single event, but rather a period of ecological upheaval that spanned thousands of years. While the asteroid impact is often portrayed as the sole cause of the extinction, recent studies suggest that it was more of a contributing factor rather than the sole cause. Instead, a combination of factors, including volcanic activity, climate change, and possibly asteroid impacts, led to the mass extinction. But life on Earth is resilient and eventually recovered. Mammals and birds experienced an adaptive radiation, allowing them to diversify and fill the ecological void left by the dinosaurs. What do you think of the new theories surrounding the asteroid impact? Do you think that it really did cause the mass extinction, or that it was just a contributing factor? Let me know your thoughts in the comments below. Thank you for watching. I hope you enjoyed this episode. Make sure to subscribe so you don't miss out on any future episodes. And as always, feel free to follow me on social media. Bye.